Okay guys, so very easy. Write 6 power minus 2 in your calculator, and what you get is 1 over 36. Okay, what 6 to the power minus 2 means is actually 1 over 6 squared, and minus power means it's 1 divided by the positive power, which is 1 over 36. To the power of a half means the square root of 81, which means 9. Now the next one's a very interesting one, alright? See, to the power of 24. There's a really easy way of doing this, alright? All you have to do is, this means scientific notation. All this means scientific notation. Okay? So all you have to do is this. Put 2 to the power of 24 in your calculator. Now you can do it 3 ways. You can keep dividing by 10 until it's a number in between 1 and 10. So look at this, I can do it, let's try this out. That's once, twice, 3, 4, 5, 6, 7. I had to divide by 10 7 times to make this work. So it's 1.67, does the next one round up? Yes it does. 1.678 by 10 to the 7. Now there's another way of doing that. If you don't remember that way, you can do 2 to the power of 24 in the calculator. Now there's a mode on your calculator. Shift setup. See science mode? Psi 0. 1.677 by 10 to the power of 7. You round it off to 1.678. If you want to change it back out of that mode, you can press Shift Setup. Shift Setup. Look, that's one more time. Shift Setup. Normal mode. Normal 1, and you're back to normal. Okay. Now, show this one here. Now, this is actually quite difficult. Okay. So, quick revision of the power rules. What's x3 by x2, anybody?
x5.
x5. What's x4 by x5? x4 to the power of 5. x20. Perfect. What's x7 divided by x3? Huh? x4. And finally, what's root of x equal to? No. X to the power of? A half. Okay. Using the rules that we all know, we're going to attack this one here. Okay? We'll see what happens. So, what we're going to get here is, I'm going to write down what a root a is. A root a is a to the power of 1 by a to the power of a half. Add the powers together and you'll get 3 over 2, or 1.5. Now, this is now a to the power of 3 over 2. What is a to the power of 3 over 2 to the power of 3?
A to the power of 9 over 6.
Because you use the multiplication technique, don't you? So it's a to the power of 9 over 2. What's a to the power of 9 over 2 divided by a to the power of 4?
A to the power of a half.
You take them away, don't you? So if you aren't sure, 9 over 2, take away 4, is a half. A to the power of a half. What is a to the power of a half?
A root a.
Root a. And there you are. Okay with you guys? Now, moving on. Yeah. So in part D, guys, it solved the question 49 to the power of x equals 7 to the power of 2 plus x. Okay? And what you have to do there is you have to get the same base number. Okay? Okay. Now the problem here is, if I said this, guys, if I said 5 to the power of x equals 5 to the power of 7, what could you tell me x is? X is what?
2.
7.
Oh.
5 multiplied by itself x times is the same thing as 5 multiplied by itself 7 times. What can you tell me x is? Yeah? Now what about this one? 5 to the power of x equals 7 to the power of 9. Can I say x equals 9?
No.
Why? They're different base numbers, aren't they?
Yeah.
So case in point brings me to this question here. They're different base numbers, aren't they?
Yeah.
What can I change 49 into?
7 squared.
7 squared to the power of x equals 7 to the power of 2 plus x. Multiplication row.
So 2x.
And what's the last part then? Power equals power.
2x equals 2 plus x.
2x equals 2 plus x. Bring the x over to your side. X equals 2. You're asked to verify your answer though. What does that mean?
Sub it in for x.
Sub in x equals 2 for x. So it's going to be 49 to the power of 2 equals 7 to the power of 2 plus 2. You can use your calculator on that. 49 squared. 2401. 7 to the power of 4. 2401. Okay. Now, do you want me to do question 4b, is it?
Yeah.
4b. Do I have 4b? I do indeed. Okay. Now, 4b, lads, it's basically 4b is a simultaneous equation, but one of them is quadratic, the other one is linear. What's the big difference between this one here and this one here? They're both simultaneous equations. Option A, option B. What's the difference between option A and option B?
B has a squared.
B has a squared in it. Well, one of them has a squared in it, you have to do the substitution method. You can't just like, remember you used to add downwards and you just say, 2x equals 8. You never do that for a quadratic linear one. Ever. You never do that. Now here's what you're going to do. You always pick on the linear. In this question here, which one's the linear?
Oh, squared.
Sorry?
One with the squared.
No, that's the quadratic.
One without squared.
The one without the square. Get one letter on its own. Which letter would you choose to get on its own?
Or.
Now you can get r on its own, but r would result in a fraction. Let me explain. 2r equals 10 plus s. r equals 10 plus s over 2. You haven't made a mistake. It's just that in ordinary level maths, we don't have to deal with fractions. Could you suggest if r is not the right choice, what's the other choice? S. It's not that it's the wrong choice, it's the harder choice. And I've never taught you that way. So always the one that bring s to the right and bring 10 to the left. 2r minus 10 equals s. Everybody right with that? Now, substitute. It's going to be r times s. So it's r multiplied by what, guys? 2r minus 10. S squared, so what happens if we square both sides? We square both sides? To find out what 2r, I'd have to find out what 2r minus 10 squared is. Yeah? I have to find out what that is. So, what happens when I square it out? 2r minus 10 and 4r squared minus 20r minus another 20r plus 100. After that, 4r squared minus 40r plus 100. I have to take away all them, don't I? Why do I have to change the sign? See the minus there?
Yeah.
That's minus everything. minus all of that. So how do I minus all of that? I'll just multiply this out first. So minus everything there.
Minus 2r. No.
Minus 4r squared.
Oh, yeah, sir.
Minus 40r.
Plus 40.
Plus 40r. Minus 100. And what about that 12? Okay. Now, how many r squared do I have? 2r squared minus 4r squared minus 2r squared minus 10r plus 40r plus 30r minus 100 minus 12 minus 112. Guys, have we ever dealt with a minus quadratic equation? What does that mean? Multiply both sides by? Minus 1. And I will divide it by 2 shortly afterwards. Divide by 2. Oh, sorry, I actually did it by mistake already, didn't I? Now, solve that quadratic equation. You can use the minus b formula, or you can factorize. 56 breaks up into
7 and 8.
minus 7 minus 8. So r minus 7, r minus 8 equals 0, r equals 7, r equals 8. I haven't made a mistake yet, but have I picked up full marks?
No, because you haven't found what S is.
Haven't found what s is. S equals 2 times whatever r is minus 10. So S equals 2 times whatever r is minus 10. Use both r values. When r is 8, what's the s value? 16 minus 10, which is, s is 16 minus 10, which is 6. Then when r equals 7, it's 14 minus 10, which is 4. Okay. What we have next is question 5. 2 functions f and g are defined for x element r as follows. Okay. We use our table function as we would, and we get all the points. So, Cameron, you tell me answers for f of x.
1.
Yeah.
1.4.
4. 1. Yeah.
2.
2.
2.8.
2.8.
4.
Yeah.
5.7.
Yeah.
And 8.
Good job. And the next one down, the G ones.
Minus 1.
Yeah.
2.75.
Yeah.
5.
Yeah.
5.75.
5.75. Yeah.
5.
Yeah.
2.75.
Yeah.
Minus 1. Or 2, sorry, 2. Yeah, minus 1.
Minus 1?
Yeah.
Okay. This one here is an n-shaped function. How do I know that?
Squared.
Minus x squared. And the other one, I think, is some form of curve like that. I'll find out now in a second. Alright, I'm going to do the first one first. I'm going to do f of x in red. These points here. The point 0, 1 is the first one. The point 0.5, 1.4, and then the next one after that is the point 1, 2. You get the gist, don't you? Okay, so first point is what, guys? 0, 1. Next point is 0.5 and 1.4. Around there. After that, 1 and 1, 2, wasn't it?
Yeah.
What's the next point after that? 1.5 and 2.8. 1.5 and 2.8, yeah? Then after that, 2 and 4. And after that, 2.5 and 5.7, yeah? And after that, 3 and 8. So, what we're seeing is it's gradually starting to curve up a bit faster, isn't it? If I was to exaggerate it, it would be a bit like this, and then it's starting to speed up a little bit. Yeah?
I didn't round it.
What?
I didn't round it.
Yeah, so you might be more accurate than I am.
Exact.
Yeah, well done. Now, what about the next one, guys? for the quadratic, which I'll do in blue. Okay, 0 minus 1. What's the next one then? 0.5 and
2.75.
2.75. 1 and 5. Thank you. Go again.
1.5, 5.75.
0.5 and 5.75. Good job.
2 and 5.
2 and 5, yeah.
2.5 and 2.75.
2.5 and 2.75. Just put the name here. And
3 and minus 1.
okay. And we see a perfect blue N-shaped graph there.
Oh yes.
Okay, something like that. Now, next page, I have this information here, and it's asking me to solve this. Okay. So, basically, I'm to use this graph. Why do we know I'm using the graph? It says use your graphs, right? So, now here's the thing. 2 to the power of x is what? 2 to the power of x is which graph?
First one, yeah, that's
Is f of x. What's this one here? 3x squared minus 9x plus 1.
curve.
Oh, it's like the opposite of the curve, isn't it? It's 3x squared minus 9x plus 1. It's the minus version of g of x, isn't it?
Yeah.
So, it's f of x minus g of x equals 0. And that basically means f of x equals g of x. When does the blue curve equal the red curve? Alright, that's pretty much nobody will spot that. Okay, it's very advanced. Hopefully it won't come up again. If it comes up again, 95% of the population won't spot it. Okay? Easy. Now,
You've just given that away on YouTube.
yes, I have. Now, guys, estimate the values of x only. So where are the two graphs equal to each other? Yeah and yeah. Yeah. So 0.3 and the other one?
2.13.
2.15, 2.13, somewhere around there. Is that alright with you guys? Now, let k be a number such that 2 to the power of k equals 6. Using the graphs or otherwise estimate g of k. Would I use this graph?
No.
Why? Looks nothing like it, does it?
No.
What could I use this graph?
Yeah. Yes.
Okay, so look for it. F of x equals 2 to the power of x. Would you agree with that?
Yeah.
Yeah? Now, how functions work is like this, alright? If I said 2 to the power of x equals 4, yeah? 4 is the output. What letter for x would turn that into 4? 2. So, this would represent the point 2, 4. Did you get that? It would represent the point 2, 4 on my graph. 2, 4 is... where's 2, 4? It's here, isn't it? Yeah? We want to find out... What we want to find out is what point has a y value of 6. When the y value is 6, what is the x value that would cause that to happen? Go up to your graph, go across y equals 6. Up. There we are. Until it hits the line. Then back down again. And where does it hit roughly?
2.7.
2.5, 2.6, in between 2.6 and 2.7. 2.65, 2.68, whatever you think. Is that alright with you guys? That's a very difficult question. Because it didn't even say x. Like, if that said x, it'd make it easy that, look, we find the x value that causes the y value to be 6. They then decided to choose a different letter on top of that. Made it really difficult.
So K doesn't actually really mean anything.
k represents a value of x. See the way it's g of k? It could be g of x. And the fact that g is there helps you figure out that that's what they were looking for. Okay, can we move on? What's the next one you want? Oh, I have nothing left yet. Long story short, guys, we have some patterns here. We need to count the amount of grey tiles. Well, how much grey tiles in the first batch?
21.
In the second batch?
33.
And in the third batch?
45.
Now, what we can see here is that there's a constant gap of 12. This makes this a linear sequence, which will be then represented by a linear equation. Okay? Now, so we have 45, go up in 12 again, 57, go up in 12 again, 69. Find it in terms of the number of tiles needed to make the end pattern. So it's just a plus n minus 1 times d. A is 21, d is 12. It's 21 plus n minus 1 times 12. And when you get 21 plus 12n minus 12, which is 12n plus 9. Everybody alright with that? Okay, 12n plus 9. Keep that number in mind. Tn equals 12n plus 9. You're asked for the 10th pattern, aren't you? The 10th pattern is T10, which is 12 times 10 plus, which is 129. Moving on to the next one. Sheila has 399 tiles. What is the biggest pattern in the sequence that she can make? I have a little cheat for this. I can go to my table function. I can use 12x plus 9. And I can start at 0, let's end at 20. Look at how many tiles the first pattern has. 21 tiles, isn't it? Keep going until you see a big number like, what are we looking for again, 399?
Yeah.
Well look, it's definitely not in the first 20, is it?
No.
So, go again. 22, 40. There it is there, in between 32 and? You have enough to make 32, but you haven't got enough to make 33. Now how would you do that without the use of a calculator? Tn equals 399. 12n plus 9 equals 399. Bring the 9 over to your side. 12n equals 390. Divide 390 by 12. 32.5. But you can't have you either have enough to make the pattern or you don't. So the maximum you can go up to is n equals 32. This will be online later, so I'm speeding through this, alright? So I haven't got much time left, so you'll get it online later. Everything you missed. Now, find in terms total number of tiles. What does that mean?
T is equals.
Imagine we have 21 in the first pattern and 33 in the second pattern and 45 in the third pattern. We need a formula to represent, if I was to make all 3 patterns, how much tiles would I need? Otherwise known as Sn, which is equal to n over 2 into 2a plus n minus 1 times d. Now, a is 21, d is 12. So what we're going to get is Sn equals n over 2. 2 times a, 42. D is 12. 12n minus 12. Then it's n over 2 into 30 plus 12n. Now, you can do something here, okay? You multiply top by top. So I'm going to get 30n plus 12n squared all over. What happens to the bottom? So top by top, bottom by bottom. 2. Divide both n by 2.
6n squared plus 15.
I have the opposite way around. 15n plus 6n squared, which is the same thing. Everybody alright with that?
Oh yes.
Okay, if not, you can just obviously have a look at it later on. Now I'm on part F, yeah? On question F, what does she want me to do? She wants me to find how many tiles I can make out of 399. How many patterns could I make? Now, if you will, I can sort of cheat with this a little bit, can't I? How would I cheat with this? I can do it two ways. The first way is, see this formula I just got a second ago? What I could do is, if I'm really stuck, I could do a trial and error method, where I go table 3 and I say 15x plus what? 6x squared. Now, can anybody describe what does this tell me from 1 to, let's say, 10? The first part tells me how many tiles I need to make one sequence. Remember the second sequence was 33. What's 21 plus 33? 54. That tells me how much I need for two sequences. What's the third sequence? 45. What's the gap between 54 and 99? 45. That tells me how many tiles I need for three sequences. Work our way down until we see 399. How many sequences can we make? 7. So you could plug in n equals 1, n equals 2, n equals 3 until you got to 7 and get your answer that way. That's entitled to high partial credit or medium partial credit. To get full credit, here's what you need to do. Sn equals 399. We need 399 tiles is needed to make n amount of patterns. Okay? What we then do is we put 15n plus 6n squared equals 399. We then move it all to one side. We go for the minus b formula, where a equals 6, b equals 15, minus b will equal minus 15, and c equals minus 399. You then go for it here and you get a minus 15 plus or minus the square root of 15 squared minus 4 times 6 times
minus 399.
minus 399.
Equals 2 by 6.
2 multiplied by 6. Cameron, do you know what that is?
Yeah.
What is it?
1089.
And when you square root 1089?
I divided it by 3. I divided all 3 by 3, so I got minus 5 plus 33 over 4, which equals 7.
Alright, just give me a second. I'm not smart enough to follow you today, I'm afraid. And 99 is what I'd get the square root of 1087 is 99. Now I'm going to get two answers. I'm going to get a minus answer or a plus answer. The minus answer is minus 15 minus 99, which is minus 114 over 12. The second answer will be minus 15 plus 99, which is 84 over 12. 84 over 12 is 7 patterns, while minus 114 over 12 doesn't matter because you can't have a negative amount of patterns. So that's your answer. Is that the last question?
Oh yeah.
That be done? Right.